In this question, we're told that two particles, A and B, of masses 5 kilograms and 9 kilograms, are attached to two ends of a light, inextensible string which passes over a smooth pulley. The two particles are held at rest 1.75 meters above a horizontal floor. The system is then released. We're additionally told, it's important to read all the way through, when in motion, each particle is subject to a constant air resistance of 3.5 newtons. Okay, we need to be careful with this 3.5 newtons and how we model it. In the resulting motion, B reaches the floor before A reaches P. So the pulley is further than 1.75 meters away. We don't need to complicate matters thinking about hitting the pulley. Alright, so let's do this. We're asked first to calculate the tension in the string. Before I can do any calculations or I can do any questions, I want to model the situation. So I'm just going to read through again. I have two particles. Here's my pulley. Here's the string going over the pulley. And two particles are hanging, being held in place. One of them has a mass of 5 kilograms, so the weight is 5g. And the other has a mass of 9 kilograms, so the weight is 9g. 1.75 meters away from the ground. I'm going to start by indicating the direction each of these particles will be moving in. The 9 kilogram particle, so that's B, is going to move down when we release this system, while the 5 kilogram particle is going to move up. So we know what's going to happen with each of these. Let's remember that anytime we have a force going through a string, there's going to be tension, which we'll model. And here's the bit to be careful with. Each particle is subject to a constant air resistance of 3.5 newtons while it's in motion. So the 9 kilogram particle, when it's in motion, it's going to be moving down. And the air resistance will be moving in the opposite direction. So that gets us 3.5 newtons heading up on particle B. The opposite, or the same actually, is true for particle A. We're going to have the 3.5 newtons going against the direction of motion. So particle A is going to be heading up. The resistance is going to be heading down. So this is how we'll model the 3.5 newtons. Okay, the model looks complete. We can start to generate some equations from there. Let's just label these. So this is A and B. And we'll start by thinking about A. So, using Newton's second law, the resultant force is going to equal mass times acceleration. T is a positive force, 3.5 and 5g are both negative. So, the resultant force equals 5a. For particle B, 9g minus t minus 3.5 equals 9a. So these two equations, I can add them together to eliminate t, and that allows me to solve for a. So eliminating t gives us 4g minus 7 equals 14a. Just going to divide the left-hand side by a and put it into the calculator. The acceleration that we get is 2.3 meters per second squared. Now that I know the acceleration, I'm just going to substitute back in and find the tension. So the tension, if I substitute into 1, I get t minus 3.5 minus 5g equals 5 times 2.3. And I can rearrange this and put it straight into the calculator. That gets me a tension of 64 newtons. Okay, so both the acceleration and the tension have been found. When I go back to the question, it actually only asked me for the tension, but I can't help but find both of these at the same time. And you will as well if you use the techniques that I've demonstrated to you. In part B, we're asked to determine the speed with which B strikes the floor. So at a point in time, B is going to hit the floor. We just want to find what speed it's traveling at when that happens. Okay, so let's focus on B. So let's collect some Suvat variables. When it hits the floor, its displacement would have been 1.75. We know it started from rest. We're looking for this unknown velocity, and we found that acceleration. That's why it was useful to do both at once. We found the acceleration to be 2.3, and the time is unknown. Okay, so the formula most appropriate here is v squared equals u squared plus 2as. If we substitute our values in, we get that v equals 4.6 times 1.75, and square rooting gets us 2.84 meters per second. That's the velocity, that's the speed that this particle hits the ground with.